Jose Vilarroig Herrera. I beg for pardon if I'm not pronouncing that too well. Jose Vilarroig Herrera is an industrial engineer, and he has a master's degree in energy efficiency and sustainability from the Jaume I University. He is currently working as an R&D technician at FACSA and chief technical officer in hydrants. He has a PhD in industrial technologies and is an adjunct professor in the mechanical engineering and construction department in the Jaume I University. I fear that Jaume I is not the correct pronunciation.
It's okay, it's okay.
Okay,
it's
thank
okay.
you. So please.
Thank you very much for the introduction. Good afternoon to everybody. Today I'm going to talk about a practical study that we have developed and we called Odour impact assessment for wastewater treatment plants using experimental and dispersion modeling techniques. So, okay, our study follows, my presentation follows more or less the same structure as the study. So first of all, we determine all the sources, other sources in our wastewater treatment plant. Then we quantify the concentration of odor on these sources. We determine some emission points in which we made this study. Then we made what we called what-if scenarios. We talked to this later. We did a brief meteorological analysis. We led to some results, and we achieved some conclusions for this study. So before going with the study, I have to say that it's a fact that during the last years, there's been a need to plan strategical investment in order to reduce the other impact in the wastewater treatment plants, which is generally made covering and deodorizing different processes involved in the wastewater treatment plant. So by the moment, the standard technique consists on having a combination on dynamic olfactometry and modeling software. In our case, we use CalPath for this modeling software, but there is a big problem with this technique that is that it strongly depends on the emission sources that you set in the software. So if the sources are not properly set, you don't have accurate results. So what's new in this study is that we have based on what-if scenarios, not just a scenario of the current operation of the plant, but what happened if step by step we are covering several processes, and we see how this makes a reduction on the total emission of the other emission. So we also make a differentiation in certain processes. For example, the primary settling tank, we divide it into two different parts. The passive area, that is a very big area, and then the active area, which is the overflow channel in the perimeter of the settling, the primary settling. We know that in the passive area there is low emission, low turbulence, and in the active areas there is high emission due to the high dispersion that is taken in that place. So, going to the study, the first part is to determine all the other sources in our wastewater treatment plants. In this case, we have a wastewater treatment plant that has two different lines. Okay, here's the first line with two primary settling tanks, then the bioreactor, two different secondary tanks, and the same with the other lines. So we have two different lines, from sludge and from water. Then we also analyzed a pumping plant, which was more or less 2 or 3 kilometers away from the wastewater treatment plants. And in total, we have 22 different points to analyze. Once we have determined all the parameters, or all the other sources, we work with a certified laboratory in order to make all the olfactometry and dynamic olfactometry, and they provide us the other concentration and the other emission values. So what is interesting for us in the sense of modeling is the other emission values. So what you can see here is what we use on our software. And the source that has the biggest odor emission was the homogenization reservoir. And then we have all the primary settling process with the passive parts, okay? You have there the primary settling line number 2, the primary settling line number 2, number 1, which are just the passive areas. And then we have the channels here that are the overflow channels. So, in fact, all the primary settling was the part that which has the biggest odor emission. If we analyze step by step all the parameters that we obtained from the olfactometry, we saw that the maximum odor concentration was in the sludge silos and in the pumping plant. However, these sources have small emission areas, so there was a reduced odor emission, and they have low impact on the total odor emission of the wastewater treatment plant. On the other hand, we have here's a little mistake, sorry, but there's no sludge silo, it's the homogenization reservoir. And there's a moderate odor concentration of 581 odor units per cubic meter. It's not so big, but there is a big emission area. If we come here, this is the homogenization reservoir. The area is very big, and even if we have a low odor concentration, the odor emission is high, so the impact is also high. And here in the part of the settling, we analyzed both the line 1 and line 2 with the passive area plus the overflow channels, and we found that the other emission was 23,945 other units per second, but this was the total, but the primary overflow channels represented the 50% of that emission. So it was very important to act over this part in particular. Later on, in order to determine the odor reduction, it was necessary to establish the emission points where the odor concentration would be analyzed, in our case using CalPAF. So these points were selected attending to sensitivity, for example, hospitals or restaurants or educational centers, then crowded areas, these parts where there are some urbanizations near the wastewater treatment plants, and finally, certain points where previous complaints were recorded. Finally, and before the simulations, we developed all the scenarios, all the possible scenarios to simulate. The first one was the current scenario with no actions taken, and then step by step we were covering different parts and different processes of our wastewater treatment plant. First, we covered the overflow channel of the line 2, then the overflow channel of the line 2, line 1. Then we add the degreaser, the sludge silos, distribution chamber, and bit by bit, we were covering different parts of our wastewater treatment processes in order to see how this covering affected to the reduction of the total odor emission of the plant. These scenarios were proposed according to the highest odor emission processes, and in this part, the opinion of the wastewater treatment plant technicians was very important because they really know what's happening, what is easy to cover, what is not, where they have the perception of more quantity of odor. So in this part, it's very important to take into account its opinion. Then we did a very brief meteorological analysis, analyzing the wind frequency distribution and the main direction of the wind. And finally, we get some results. Basically, two kind of results. On the left side, you can see the quantitative results, and then the qualitative results on the left, on the right. For the qualitative, we use these areas which mark the odor impact of the 98th percentile 1 hour, with the current scenario with no actions taken, and then with the scenario number 6 with all the actions taken. So you can see that it's a big reduction on the area which affected in the no action and in the scenario number 6. On the other hand, we also have a graphic which shows how the odor emission is being reduced as long as we are reducing also or covering all the different processes. So we can start from an 8.5 reduction and lead until 59.6 reduction, depending on which processes we are we are covering. So for this study, we concluded that we did a new measurement methodology in the sense that we use a what-if scenario. We don't use just one scenario, but a what-if scenario, several scenarios, and analyzing what happened in each scenario. We had to do a new technique or try to make something special in order to measure with the limbal bell in the overflow channel, which is not usual. And then the results show that the primary settling overflow channels, Odour emission, varies between 36 and 65% of the total emission of the settling, of the primary settling process, which is a non-negligible value. Finally, well, we also find that the best solution in this case was to coverage the primary settling overflow channels, which represent a reduction of 22.3% of the total emission of the wastewater treatment plant. This was an affordable and cost-effective solution, and that's why it was taken. And finally, it would be interesting to act over the homogenization reservoir, since this focus could lead into a reduction of 60% of the total Odour emission. However, due to technical and economical issues, this could not be possible, so we have to stay on covering the overflow channels. And that's all. Thank you very much. And if you have some answers, some questions.
Thank you very much, Jose. I would like to know if there are any questions from the audience. Yes, I can see a lot of hands raised.
Okay, thank you for your presentation. Could you please come back to the picture where we have the flux chamber on the homogenization reservoir? Because I do not understand.
This one?
No. Where you have the flux chamber.
The
flux chamber.
The float chamber.
Yes, this one. So, can you explain a little bit? So it's a film with
this plastic. This
yeah.
is a film of this is the limbal bell, which is used to measure in the passive area, but in some way we have to measure on the overflow channel. So we talk with the lab, and they offer us this solution in order to have the measure on the overflow channel, to have some results.
Okay, so you don't know exactly the surface of emission.
We know the value on the surface, and the overflow channel was measured with this technique, using this.
Yes, I'm a little bit surprised, to see this kind of protocol, because
there was no other way in order to measure on the overflow channel, since it was difficult to do it in another way.
Yes, I know it's difficult, and I know that it's always imprecise, but even in that case, you add something more, because you don't know exactly the surface that is sampled.
No, but
and you don't know the real flow inside, because you have quite a big distance between your inlet and outlet comparatively to the source.
Yeah, I agree with you. But
just to mention that you have probably a higher uncertainty that we have not normally in that case.
Yeah.
Okay. Thank you.
I have a question. Perhaps I missed it, but when you calculated the reduction in odor after covering certain units, did you assume that you have 100% reduction by covering the facility?
No, we measure we calculate different percentiles with a Kalpoff model, and we compare its value with the current scenario. All the percentiles were compared with the current scenario, and we saw the reduction on the percentiles that we get.
No, I mean, what technology do you use to treat the odor in the covered elements? I mean, what did you consider?
to
Like
treat
you cover the stabilization reservoir. Okay, you cover it, but how do you treat the air?
But we just also proposed, okay, we proposed to cover them. Then we saw what we proposed, okay, what happened if we cover this part or we cover that part? And we saw how this reduces with our modeling, so the modeling, how this reduces the impact that we have. Once we know that this could be able or this could be interesting to do, we have to think about the technology that we have to use in order to get this into a technical part. So in the case of the homogenization reservoir, it was a problem because it was not possible to cover all of this. That's why this option was just removed. It was not considered.
Okay, thank you very much, Jose, for your answers and for your presentation.
Thank you.